Okay folks, welcome to our second review video for GED Math. Here we're going to look at some fractions and number lines and decimal numbers, and then we'll get into some proportions and ratios after that. So you might recall that our number line, when we draw a number line, we can use whole numbers, or we can use decimal numbers or integers. We can have positives and negatives, therefore. And so it's a good representation to help us see, help us compare numbers and help us see how numbers are changing, how values are changing. So let's try a couple of practice questions. So in question 1, what is the value of the point on the number line below? So we can see that the point is halfway between 1 and 1/3. And so sorry, it's between 1/3 and 1. And so if we want to figure out where that is, we can find that midpoint on the line. We can say that the value is going to be, just add the values and divide by 2. So we have 1/3 plus 1. And then we can divide that whole thing by 2, and that's when we get a common denominator in our numerator there. That gives us 3 over 3 plus 1 over 3, which is 4 over 3 over 2, which is 4 over 6, which is the same as 2 over 3. And so our answer is C there for that one. Let's try number 3. In the number line below, what is the value of A minus B? So A minus B is equal to, so our A value is 3 1/2, so 3 1/2. And we're going to subtract the B value, which is 1 1/2. So we should rewrite these as improper fractions. So 3 1/2 is the same as 7 over 2. And 1 1/2 is the same as 3 over 2. So we have minus 3 over 2. So 7 minus 3 gives us 4. So we get 4 over 2, which is equal to 2. So our answer for that one is C. Okay. Let's see here. Let's take a look at some decimal values here. These are a little bit different. So number 5, for each of the number lines below, fill in the value of the point using decimals. So this is a value that's directly, it's right in the middle between 4.5 and 4.75. So again, similar to what we did before, we can add those together and divide by 2 to find the point that's midway between them. So 4.75 plus 4.5, and then we divide that whole thing by 2. And so we get, that's 8, so 9.25, so 9.25 divided by 2. And if we, you could use your calculator for this one, but if you don't want to use your calculator, 9 divided by 2 gives us 4.5, and 0.25 divided by 2 gives us decimal 125. So then we have 4.5 plus decimal 125, so 4.625. So 4.625. So this is our 4.625. So in that's a similar question to question 1, where we're finding the midpoint between those 2 points on the number line. Just going to save this document here. And this review is going to be for June 20th, Saturday, June 20th. Okay, let's take a look at something different. So there are some calculator skills there to help you with some decimal numbers and some fractions. And so that's all pretty straightforward, just adding decimal values together and subtracting decimal values. And so that's just more calculator work. So that should be pretty straightforward. Decimals and fractions can be a little bit trickier though. So for these ones you may use your calculator, but you don't have to. In some cases you may find you don't need to. So a wooden flooring strip is 20.5 inches long. If you cut off 4 3/4 inches from one end, what will be the new length of the strip in inches? So here we've got 20 1/2, and we're going to cut off 4 3/4 inches. So we're going to subtract 4 3/4 from that. So converting those to improper fractions, we get 2 times 20 is 40. So we have 41 over 2. And we get 4 times 4 is 16, plus 3 is 19, so plus 19 over 4. And our common denominator is 4 there. So we get 82. Oh, that should be a minus sign up there, my mistake. Sorry about that. I'm just going to fix that one. Okay, this should be subtract. Okay, so 82 minus 19, and that whole thing is going to be over 4. So 82 minus 19 gives us 63, so it's 63 over 4. And so to convert that back to a mixed fraction, then 4 goes into 63. It doesn't quite go in 16 times. Because 4 times 16 gives us 64, so it's going to be a little bit less than 16. So it can't be A or B. So it's going to be either C or D. So 4 times 15 gives us 60, so it's 15. But then we have 3 left over, and so it's 15 3/4. So it's got to be C for that one. Okay. Let's try number 6. Gina is paid $8 an hour. If she earned $258 in 1 week, how many hours did she work? So we know that her pay has to be equal to the rate of pay times the number of hours that she works. And so we know that her pay is $258, and we know that her rate of pay is $8 per hour. We'll say n is the number of hours, and so to get n by itself, we divide both sides by 8. So we have 258 divided by 8. And if we divide 258 by 8, I'm going to get my calculator out now for this one. Let's see here, utilities, calculator. Okay, so we've got 258 divided by 8, and that gives us 32.25, but 0.25 as a fraction is 1/4, so it's 32 1/4. So n is equal to 32.25 hours. And so it's got to be 32 and 1/4 right there. That one. All right. Let's move on to something different. Got some more fraction work there. Let's try this one. We'll do one more with fractions and then look for some work in ratios. Jim and Carl have until 1 p.m. to load 250 boxes. By 12:30 p.m., 175 of the boxes are loaded. What fraction of the boxes has not been loaded? And so our fraction, they've to find out how many have not been loaded, we take 250 and we can subtract 175, because that'll tell us how many boxes have not been loaded. So 250 minus 175 gives us 75. So 75 boxes have not been loaded. So we have 75 boxes out of the total number of boxes is 250. And so 75 divided by 250, because the total is 250, so 75, we can divide both of those numbers by 5. And if we divide them both by 5, then we get 15 over, so 250 divided by 5 gives us 50, but we can do better than that. We can divide by 5 again to get 3 over 10. 3 over 10. And so we have something like that. And a few more on number lines. We've done some of those though, so let's see. Lots of practice on some of those fractions. Here's a decimal number question. 25 refers to the map. So Maya drives a van that delivers supplies to each of the stores. On Friday, she traveled the following routes: so A to B, B to C, C to D, D to C, and C to A. And so we have to do some addition here. We have to look at A to B. So A to B is 2.4 miles. And then she goes B to C, and B to C is 4.3 miles. And then C to D is 3.6 miles. And then D to C is going to be 3.6 again. And then C to A is going to be 4.3 plus 2.4, which gives us 6.7. To go from C to A. And now you can use your calculator for these, or you could add them up as a stack like this. So 4 plus 3 is 7, plus 6 is 13, plus 6 is 19, and then we get plus 7 is 26. So we put a 6 here, we put a 2 up here. We've got our decimal there. Then we've got 6 plus 3 is 9, plus 3 is 12, plus 4 is 16, and then plus 2 is 18, so we get 20. So 20.6, so 6, 3, 6, 9, 12, 14, 18, yeah, that looks about right. So 20.6, except that's not on there. Alright, better double check our answer then. Maybe I read something wrong. So she goes from store A to store B which is 2.4. Then she goes from B to C, which is 4.3. Then she goes from C to D, which is 3.6. And then she goes from D to C, which is again 3.6. And then she goes from C to A. And so from C to A, she's backtracking and going 4.3 plus 2.4, so that's 6.7. Okay, so I think my stack of values is correct. So 7 plus 6 is 13. Then I get 16, 22, 26. So I've got a 6, and then I carry the 2. And then I've got 6 plus 6 is 12, 14, 18, 20, 20.6. How many miles did she drive in all? To me, that looks correct. So I'm going to make a new answer. And I'm going to say it's E. And E is 20.6. There we go. I wonder if they meant she goes from C to B instead of from C to A. Because then her answer would be reduced by 2.4. So that would be 20.2, 18.2. No, they don't have that as an option. Oh well. It's a mystery. Okay, so ratios and proportions. So these are common types of questions as well. So a ratio is really just a comparison of two values, and we can write ratios with a colon like this, or we can write it in words like this, well, with the word 2 anyway, or we can write a ratio as a fraction. So there are different ways to write ratios, and we can use them to solve lots of different kinds of problems. And so let's just try, here these ones are just asking us to write some ratios, so let's try writing some of these ratios. Carol's monthly take-home pay is $1,500. She spends $250 a month on food. What is the ratio of food costs to take-home dollars? So the ratio would be 250 to 1,500, but we should reduce that. So we can divide both of these values by 250, and so then we get 1, 2, and 1,500 divided by 250 is 6, so 1 to 6 is the ratio for food costs to take home dollars. Okay. How about number 5? Juanita drove 336 miles on 14 gallons of gasoline. What is the ratio of miles to gallons? So this ratio is going to be 336 miles to 14 gallons. Now we can reduce this. We certainly can divide both sides by, or both parts of the ratio by 2. So that gives us a 7 on the right-hand side of the ratio. And 336 gives 150, 168, 7. I think that's as low as we can go with that one. I'll double check though, just in case we can divide by 7. So 168. 168 divided by 7. Oh, we can. It's 24. I stand corrected. So we can reduce this further. So this would be 24 to 1 for the ratio of miles to gallons. So we could say that this vehicle gets 24 miles per gallon. And that's a way to measure efficiency for fuel use. So that's those are some good examples for ratios. Let's look at number 14. A team played 77 games and won 56 of them, and there were no ties. What is the ratio of wins to losses? So 56. So we need to know a number of losses. So losses is going to be 77 minus 56, which is, so 77 minus 50 would give us 27, and so we get 21. So wins to losses will be, so the ratio, oops, not ration, the ratio is equal to, we want wins to losses, so it's 56 wins to 21 losses, and then we can divide those both by 3, I think. So let's see, or can we? 56. So 54 divided by 3 gives us 18. So then we can't do that. 56. So 3 times 18 gives us 54. So we can't divide that by, oh, we can divide by 7. Oh, silly me. Of course we can divide by 7. So 8 to 3. Yeah, there we go. That took me way too long. I'm sorry. Okay, so 14D. It's been a long day. But that's no excuse. Okay. All right, here are some proportions, and so proportions are ways that we can use ratios to solve problems. So we can write ratios as fractions, and we can, in some problems, we can set one ratio equal to another, so we can solve for a variable. So let's try this one, number 13. So we've got x that we want to get by itself, so we want to multiply both sides by 114, and so we get x, we'll leave x on the right hand side, and now we've got 3 times 114, and we're dividing that by 19, and so x has to be equal to, so 3 times 114 over 19, I'll try my calculator, 3 times 114 divided by 19, and we get 18 for that one. Alright, so x is equal to 18. Okay. So that's, the rest are similar, except this one's a bit different. So when we have the variable in the denominator, we want to multiply both sides by the denominator first. So we have x times 24 over 96 is equal to x times 7 over x. So now we can say that x divided by x gives us 1, so that those cancel, and we get 24. Actually, let's find out what 24 over, let's do it this way, 24 over 96. So we're going to multiply both sides by 96 and divide by 24. So x therefore is equal to 7 times 96 over 24. Now I can divide 96 by 2 to get 48. And then, so that's going to give me 46, but 96 divided by, that means that 96 divided by 24 is 4. So that equals 7 times 4, which gives me 28. So that's a couple more steps there when we are solving for the variable that's in the denominator. Okay, let's try number 21. 2 ingredients in a recipe are 2.5 cups of flour and 1.5 cups of sugar. If June keeps the proportion the same, how many cups of flour should she add to 4 cups of sugar? So we want to know how many cups of flour she's going to add. So we want the value for flour in the numerator. So we have x over the amount of sugar she's using, so 4 cups of sugar, equals, and the initial amount of sugar is 1.5, so 1 and 1/2, and we have 2.5 cups of flour. But it's better to write those as improper fractions, so x over 4 is equal to 5 over 2 over 3 over 2. So we can write x over 4 is equal to, so we're dividing by 3 over 2, which is the same as multiplying by 2 over 3. So we get 5 over 2 times 2 over 3. And so we have 2 divided by 2 gives us 1. So we can cancel those, and we get x over 4 is equal to 5 over 3. So x has to be equal to 4 times 5 over 3, which is 20 over 3, which is 3 goes into 20 6 times, and we're left with 2/3. So 6 2/3 is our answer for that one. All right. All right, let's see what else we have here. Percents. Okay, so if we want to write a percentage as a decimal place, we have to divide by 100. So 25%, as we can see here, 25%, we just move the decimal place 2 places to the left. So there's an example of how to convert a percent to a decimal. Converting a percent to a fraction, we just write the value over 100 and reduce the fraction. So 25% is 25 over 100, which reduces to 1 over 4, or 1/4. Okay, let's try some of these. Kayla bought a dress for $38. She paid $3.23 in sales tax. The sales tax rate in her state is 8.5%. So we want to identify the base, the part, and the rate. So the rate for this one, the rate is 8.5%, and the base, if we look back at these definitions, so the base is the whole quantity, and the part is the portion that we then find out what it is as a percent. So in this case, the base is the original price, so the base is $38, and the part is the sales tax, which is $3.23. So that's just a question about definitions, and those ones will all be very similar. Okay, For questions 11 and 12, refer to the following information. A local newspaper printed the following high school basketball standings. So there we see the standings. Which of the following expressions could be used to find what percent of its total games Fairfax has won? So Fairfax, when you look at the Fairfax information that's up here, we've got that team has 9 wins and 3 losses. So we have, we want to find the percent of its total games it's won, so it's wins over total games. And then once we divide that, we'll get a decimal number, we'll multiply it by 100, and we'll write percent on the end. So we have the number of wins for Fairfax is 9. The total number of games is 12. So that's times 100%. And 9 over 12 is the same as 3 over 4 when we reduce it, so it's 3 over 4 times 100%. And 3 over 4 is, as a decimal number, is 0.75. And then we're going to multiply that by 100%, which gives us 75%. Oh, they want a fraction for that. So we would have 9 times 100 over 12. You had me there. So 9 times 100 over 12. Took that one too far. My apologies. Good practice, though. Okay. What percent of its games did Bravo win? So this one we have to go further, right? So for this one, we'll have wins over the total games, which is, for Bravo, it's 6 over 12. And if we reduce that, we can divide both by 6, so we get 1 over 2. So this is going to be times 100%. So times 100%, which gives us 100 divided by 2, which gives us 50%. So that is the percentage for Bravo's wins. Okay. So using the percent formula, this is a good way to think of it, using the base. So here's a representation of the percentage formula, using the base, the rate, and the part. So you can just, if you want to find the part, then you multiply the base times the rate. If you want to find the rate, you divide the part by the base, etc. So that can be a helpful little diagram there. Okay. These are more or less calculator problems. We can do a few. This one actually I don't think is, but so 240 is what percent of 120? So 240 over 120 is equal to 2. So so we're going to multiply by, and this is, I'll go back and I'll put that extra step in. So same as what we did before, we're dividing and then we're multiplying by 100%. So we end up with 2 times 100%, which is 200%. Okay, let's try this one. So $0.65 is what percent of $10? So 0.65 over 10 times 100% is what we're looking for. So 0.65 divided by 10 gives us 0.065 times 100%, which equals, multiplying by 100, we just move the decimal place 2 places to the right, so we get 6.5%. All right. That's some good stuff. All right. Lydia pays $3 tax, sales tax on a $50 purchase. Which of the following expressions could be used to find the sales tax rate in her state? And so we know that we've got, thinking about our formula, I'll write it over here, I guess. We've got the part over the base times the rate. Oh, that should be times though. So the part is equal to the base times the rate, etc. So we can put that in our triangle or our box, whatever you like. So we want to find the sales tax rate, so we would cover up the R, and so we can cross it out here. We're going to get rid of the R, and so we want to find R. So R is going to be the part over the base. And so we have, so she says she pays, and that's, we have to multiply this by 100, of course. So we have, she pays $3, so the rate is equal to the part, which is $3 that she's paid, and then we multiply by 100, and then divide by 50. We want a percentage, so it's 3 divided by 50, but that's going to give us a decimal number that we multiply by 100 to get that as a percent. So this answer A is the best one that I can see, I think. All right, moving along. So this is more work with the formula for percentages, and a little bit of work with division, long division. And so we've got, yeah, I think these are just examples using long division. So that's the main difference here. So let's see here. You may not use a calculator for these. All right. So $42 is what percent of $168? All right. So let's take a look at that one. So $42. So 42 over 168. And then we want to multiply by 100 to get the percent. And so we can divide 42 into 168. And we might need some decimal numbers here. We can put in some zeros if we want as decimals. All right, so 42 goes into 168 how many times? So 42 times 4 gives us 168, actually. Oh, I guess we didn't need long division, so this goes in 4 times. So that tells us that 42 over 168 is 1/4, so it's 0.25 is 1/4 times 100%, which equals 25%. Okay. Let's see, we've got 126 and 140. That's probably going to be something similar. 15% of 62 is what amount? 9 is 1% of what number? Alright, let's try number 12. So 15% of $62. So using our formula, so we want to multiply now. So 15% is 0.15 times 62. And so we can go 62 times 0.15. And so we get 5 times 2 gives us 10. So we'll put a 0 there and carry the 1. 5 times 6 is 30, and we get 31. Sorry, my mistake here. Yeah, 5 times 6 is 30 and 31, so we get 310. And then we've got, we do the next column here, so 1 times 2 is 2, so we'll stick a 0 here. So 1 times 2 is 2, and then 1 times 6 is 6. And then in our next column there, we've got, we'll put 2 zeros here. We've got 0 times 2 is 0, and we've got 0 times 6 is 0, like so. And we get, when we add these up, we get 0, and then we get 3, and then we get 9, and we've got 2 decimal places we have to that we've got from above. So we've got 9.30. So what amount? So 15% of $62 is $930 for that one. Okay. Okay. Choose the one best answer to each question. So here's some more multiple choice. Let's see. So a city council, can we use calculators for this one? You may use a calculator. Okay. That's good. So a city council established the following budget to improve public transportations. We've got some percentages there in different categories. If $72,000 is allotted for equipment, what is the total budget for the project? So $72,000 is allotted for equipment. So the part is $72,000, and the base is what we don't know, and the rate is we look up for equipment, and equipment says 6%, and so we want to know the base. So the base from our triangle, if you look up here, triangle we wrote down, well, here it is, the rectangle. This rectangle is going to help us. So the base is the part divided by the rate, right? Because our base would go here. So that's not a very good B though. Let's try that one again. All right, and so going back down here, we've got the base equals the part divided by the rate, which equals 72,000 divided by, but the rate has to be a decimal number, so 6% is 0.06, and so I can use my calculator here, so that gives us I suspect this will be a big number. 72,000. So 72,000 divided by 0.06. We get 1,200,000. So it's this one here. C. So $1,200,000. There we go. Okay. So just there's some information on calculator skills and so forth. And I'll put this document. I'll upload this document into our notes area as well. So you can do extra practice if you want. Okay, so we've got we can solve these, and you can use your calculator if you want. So let's try this one here. So what is 12.5% of 384? So we want to know what is the part. So the part is equal to the base times the rate, which is equal to 384, which is our base, times, so 12.5 is 12.5%, or 0.125 as a decimal number. And so we can multiply those. So 384 times 0.125. So we have 5 times 4 gives us 20. So we'll carry the 2 up here. 5 times 8 is 40, and then that gives us 42. So 2 here and 4 here. And we go 5 times 3 is 15, plus 4 is 19. 9 there, 1 there. Actually, this should go here, because we're not multiplying anymore, so you forget that. Okay, and then we have the next column, we'll put a 0 here. So we got 2 times 4 gives us 8. 2 times 8 is 16. So that's going to give us, let's see, 2 times 8 is 2 times, so that over here, I'll put in our 1. So 2 times 3 is 6, 6 plus 1 is 7. Okay, and then we'll put our 2 zeros here. And we go 1 times 4 is 4. 1 times 8 is 8. 1 times 3 is 3. Okay, and then the rest is zeros. I don't have to do those. So we get 0. Then we get 8 plus 2 is 10. We'll carry a 1 up here. No, it's 10, 16, 20. 2, 3, 10, 18, and then 4. We got 3 decimal places, like so. So 0 decimal, so 12.5% of 384 is 48. So therefore, the part is 48. And you can check that just with an estimate. It's just estimating your answer. So 12.5% is a little bit higher than 10%, and 10% of 384 would just be 38.4. So you know the value has to be bigger than 38.4, and so 48 sounds pretty reasonable for that one. Okay. Okay, a baseball player has the following statistics to the nearest percent. What percent of the players' at-bats were strikeouts? Okay, what percent were strikeouts? So how many at-bats did they have? They had 410. So out of 410, how many were strikeouts? 63 were strikeouts. So if we use our calculator, we just divide. So 63 over 410. 63 divided by 410. And we get 0.153, which gives us 0.153, which is approximately 15.3%. So that's the best answer right there, D, 15%. All right, simple interest. So this is building upon the idea of percentages. So simple interest, to calculate simple interest, we have it's I equals PRT, which is principal times rate times time. So there's your formula. And, or if you want the short form, I equals PRT right there. And so let's take a look here. Maybe we could do an example or two. So Todd invests $6,500 for 3.5 years at 5% interest. How much interest will he be paid at the end of the time period? So the interest here is equal to our PRT. So our principal is $6,500. The rate is 5%, so that's 0.05. We have to write as a decimal number, and then times 3.5, which is times 3.5. We can write that as a decimal number. And it says we may use our calculator for this, which is great. So 6,500. So 6,500 times 0.05 times 3.5, and I get 1,137.5. So 1137.5. So 1137.5. So $1,137.50 is what we get for that one. All right. All right, let's do one more. Okay, Charlotte needs to borrow $2,500. She's considering 3 loan options shown above. How much more interest would Charlotte pay if she takes loan option C instead of option A? So for A, let's see how much she would pay. So interest equals PRT, which is our principal. I should give myself some more room there. So let's do that. Principal is $2,400 times the rate. So in scheme A, interest rate is 0.12, so we're converting to a decimal number, times the time, which is 2.5 years, which is 2.5, which gives us, so 2,400, so 2,400 times 0.12 times 2.5. We get $720. So $720. And then for B, interest is 2,400 times the rate for B. Oh, sorry, this is C. My mistake. This should be C. C. We'll correct that. C. So 2,400 times decimal 0.9 times 4 is So let's see what we get there. 2,400 times 0.09 times 4. And I got $864. So $864. So if I subtract, so $864 minus $720. So that's going to be, let's see here, 864, so 844, $144, it looks like, right there. Okay, and that is all we have time for today. So, that's our second video lesson, and I will hopefully see you all next week.